Welcome to our Quantum Deep Dive.
Today, we are diving into a really fascinating essay by Jörg O. Schnepplet. It's all about a physicist whose single breakthrough theory didn't just solve one of the biggest riddles in physics, it actually laid the groundwork for the technology of our future.
So, picture this. Electricity that can flow forever, with absolutely zero loss of energy. I mean, it sounds like something straight out of sci-fi, right? But it's a real thing. It's called superconductivity. And for the better part of 50 years, nobody had a clue how it worked. It was a total mystery.
Right, so let's set the stage here. This whole thing kicks off way back in 1911. A Dutch physicist, Heike Kamerlingh-Onnes, discovers that if you cool mercury down to a super low temperature, its electrical resistance just vanishes completely. For the next 46 years, the smartest people on the planet threw everything they had at this problem. I mean, we're talking about the giants of physics, and they all came up short. They could describe what was happening, but they couldn't explain how or why.
Yeah, the core mystery was just mind-bending. How could this collective macroscopic quantum state just pop into existence? Imagine a crowded room with billions of people just milling about randomly. Then, in an instant, they all start moving together in a perfectly synchronized dance, flowing through the room without bumping into a single thing. How does that happen? Classical physics had no answer. Even the early quantum theories were stumped. So if the old guard couldn't crack it, who could? Well, the answer finally started to take shape at the University of Illinois. A team came together, a really powerful collaboration of three very different minds, all focused on solving what seemed like an impossible problem. And what a team it was. You had John Bardeen leading the charge. This guy was already a titan in the field. I mean, he'd already won a Nobel for co-inventing the transistor. Then you have Leon Cooper, a brilliant theorist. And the wild card, J. Robert Schrieffer, a young, super sharp graduate student who brought a totally fresh perspective. It was that combination, the seasoned veteran, the deep thinker, and the young gun, that turned out to be the magic recipe.
Okay, so the first big crack in the case came from Leon Cooper. He figured out something that seemed totally counterintuitive. You know how electrons are all negatively charged, so they should repel each other, right? Like pushing the same ends of two magnets together. Well, Cooper showed that under the right conditions, they could actually pair up. They do this by kind of talking to each other through the vibrations of the crystal lattice they're in. This little dance creates a weak attraction that overcomes their natural repulsion, and these became known, fittingly, as Cooper pairs.
Now that was a massive piece of the puzzle. Huge. But it only explained how two electrons could get together. The real challenge was scaling that up. How do you get from one single pair to the billions upon billions of electrons in a piece of metal, all acting in unison? How do they all decide to form pairs and create this perfect frictionless quantum fluid? That was the next and much bigger mountain to climb.
And they were stuck on this for months. You can just imagine the intense debates, the chalkboards filled with equations, hitting one dead end after another. And then, the final piece of the puzzle, the big aha moment. It came from the grad student, from Schrieffer. And get this, it didn't happen in some fancy lab. It happened during a train ride from New York to Illinois in February of 1957.
Right there, on that train, he scribbled down what would become one of the most important equations in modern physics. It's called the BCS wave function for Bardeen, Cooper, and Schrieffer. It looks complicated, but what it does is pure genius. It describes the entire ocean of Cooper pairs, all of them, as a single, unified quantum state. Not as separate couples on a dance floor, but as the dance itself. It was the complete recipe for superconductivity.
And that right there was the huge paradigm shift. The old way of thinking was, electrons are like a chaotic mob of particles, bouncing off the atoms in the metal, which creates resistance. It's messy. But the BCS theory? It showed that they're more like a perfectly synchronized orchestra. All the Cooper pairs are phase-locked, moving together in perfect harmony as one single macroscopic wave. When they move like that, there's no friction, no scattering, just a perfect, effortless flow. So, when they published their theory of superconductivity back in 1957, it was way more than just an academic victory. I mean, yes, it finally answered that 46-year-old riddle, but it also, quite literally, fired the starting pistol on a whole new era of technology. And the fallout was immediate. The theory was tested, and it checked out perfectly. A few years later, in 1972, the trio, Bardeen, Cooper, and Schrieffer, rightfully got the call from Stockholm for the Nobel Prize in Physics. And almost overnight, engineers started to realize what this meant. They could now start building things that were, until that point, strictly in the realm of science fiction. Seriously, you can't overstate the impact. The legacy of that theory is woven into the fabric of our modern world. Every time someone gets an MRI scan, that's a powerful superconducting magnet at work, and it's built on BCS theory. The massive particle accelerators, like the Large Hadron Collider at CERN that are smashing atoms to figure out the secrets of the universe, same thing. And now, at the absolute cutting edge of science, quantum computers, superconducting circuits are one of the leading ways we're building qubits. It all comes back to that equation Schrieffer dreamed up on a train. But the story of Schrieffer himself is, well, it's more complicated. His legacy isn't just about this one incredible theory. It's also about his influence as a teacher and a mentor, and about the complexities and challenges of his own life. Absolutely. In terms of physics, he didn't just solve a problem. He gave physicists a whole new language, a whole new framework for understanding these weird collective quantum phenomena. That framework is now used to explore everything from superfluids to quantum gases. He even wrote the textbook on the subject, literally the book that taught generations of scientists how to think about this stuff. And as we mentioned, his life was also a story of deep human complexity. You have this towering scientific achievement on one side, but on the other, he faced real personal challenges later in life, culminating in a tragic car accident back in 2005. It's a stark reminder that these scientific giants are human beings, and that science itself is always, at its core, a human endeavor. And that really brings us to this quote, which I think says it all. For Schrieffer, it was never just about the beautiful, abstract math on a chalkboard. A theory, for him, only found its true meaning when it was tested out in the real world and actually did something useful for people. And looking at everything from MRI machines to quantum computers, you've got to say, his vision was realized in the most spectacular way imaginable. So, as we've explored in this look at Grzegorz Schneppat's fantastic essay, the work of Schrieffer, Bardeen, and Cooper didn't just close a chapter in physics, it blew the doors open to countless new ones. I mean, think about it. A theory that's over 60 years old is now the engine powering our quantum future. It just makes you wonder, what's it going to unlock next?
Thank you for joining us. For more and to read the original essay, please visit schneppat.de. Goodbye.
Schneppat.de is a private project by Grzegorz Schneppat dedicated to promoting quantum technology. Its mission is to present knowledge in a way that is clear, precise, and transparent for those just starting out, as well as for experts who wish to deepen their expertise. He firmly believes that education and access to well-structured information are the keys to unlocking the full potential of this future technology. If his work helps you realize your own visions and actively and consciously shape quantum technology, then the goal of his project has been achieved.